My project is the mini sumo robot. This robot is designed to spin around first, and then it will eventually hit something within its range of 20 centimeters. I'll explain. So right now it is spinning, looking for something to actually fit in something. When I place something in front, it will bump into the edge of the scene right there. To spin, as I said, until it has seen something with ultrasonic sensors, which ranges for 20 centimeters, which I put that code in the Arduino Uno, which is the microcontroller. I had three biggest problems with this. First one is the first 2 weeks that I have done this, it is the actual motor driver that came with the project. Now that motor driver was too difficult to work with. It was too big for this chassis, and it was just really difficult. The way how I fixed this is I removed that, took it out, and then I replaced it with 3 H bridges. The reason for 3 is because when I use 1, it will overheat, and it will just completely die out if I just use 1. I placed the 3 H bridges in parallel, or stacked up upon each other to make it more efficient in making it move. The second biggest challenge was actually coding it. See, I have no experience, little to no experience in computer science or anything with coding. So I had to actually struggle with learning the Arduino code and how to code and what the code actually does. So that's how I faced it. I learned with hard work. The last problem was the actual building of the entire robot. Now, the body of this robot was built too small, so it's really hard to fit everything in there. So the thing I did was file it down. And that worked for parts of these. But the wheels are the worst. The wheels have to be filed down from the center to make them move freely. When I first used this, I had a drive belt. The drive belt will make it into an all-wheel drive. However, with the drive belt, the entire thing had too much friction, making the wheels not move at all. So I took that out completely, and I just left it as it is. Now for my experience here, it is a wonderful place. I learned a lot. I learned how to solder. I learned basically all the principles and skills that I need to go into college. And I'm a rising senior, by the way. And yeah, but the next thing that I will do is actually put in a power switch. Because as you can see from my presentation, I had to plug it and unplug it, which is quite a lot of work. And for my major, I would love to do engineering. Basic engineering in general. Because I learned that mechanical engineering, electrical engineering, computer science, they all tie together in this one thing, robotics. Which some colleges would probably have that major, but I would rather do all basic engineering. Thank you. Yes?
What do you see as application? An application for that?
Well, this is more for like fun, or like when you want to, let's say, go into a competition for robotics. You will have to, this is a mini sumo bot, so it'll do exactly what a sumo wrestler would do. Push things away and sense them. And since this is like not really like a ring right here, but if you imagine like a fight between 2 robots, like there's like a TV show for that, you would use this and then it will just battle the other robot, basically, just for fun. Any other questions? Yes, Aaron?
What was the cause of the like high volume of friction that you were encountering with your wheels?
The drive belt was actually smaller than it should be, so that caused too much tension around the wheels. And also the wheels itself, the center of it had too much plastic since it's 3D printed. So I had to file down the center of that to make it less friction, like make it rotate easily. Yeah, basically. Any other questions? Yes?
Are you saying that you 3D printed all of these parts?
Not all of them. The wheels, the chassis, and the ramp that is shown right here. That is all 3D printed.
So why did you choose to file them as opposed to reprint them?
Because when you reprint them, it will take longer. as to when you file them, you would have a much easier chance to, you have more margin of error when you file. Because if you file them too much, you could still use a, what I did was use an axle retention to hold the wheels into its place instead of having them slide off. Yes?
Which of the engineering disciplines was most difficult for you?
The coding itself, I had no experience, so I had to research. I asked Kevin, I asked a lot of people for help. That's basically the entire thing of this thing. For 2 weeks straight, it's coding, coding, coding.